Okay, then so far we have found the x-coordinate of each point at which f attains an absolute maximum value or an absolute minimum value. And for each coordinate you give, you have to state whether it is the absolute max or the absolute min. And so the absolute max is going to occur at f of 0, which happens to have a y value of 1. And the absolute minimum will occur at f of 2 and at f of negative 2. And the y value there is negative 1. Alright, so what we want to do next in part B is to find the x-coordinate of each point of inflection of the graph. And recall what the point of inflection is. Point of inflection is where the second derivative changes sign. Alright, so let's take a look for a second at where the second derivative changes sign. So if you notice from x equals 0 to x equals 1, and then from x equals 1 to x equals 2, the second derivative goes from positive to negative. So that's definitely a point of inflection there. Now the only other question would be then, is there any other places where the second derivative changes sign? Now if you notice from x equals 1 to x equals 2, it's negative, and then from x equals 2 to x equals 3, it's also negative. So f of 2 is not a point of inflection. And it appears that the only place where we have a point of inflection is going to be at x equals 1. And it has to justify, and so I say that x equals 1 is the only point. Now I do catch myself, so remember that because this is an even function, it is reflected over the y-axis. And so x equals 1 and x equals negative 1 are the only points. So I rewrite that. X equals 1 and x equals negative 1 are the only points on the graph where f prime prime of x changes signs. And so that's a sufficient answer for B. What we're going to do next then is in part C, in the xy plane provided below, sketch the graph of a function with all the given characteristics of f. Now in this case, what I would always do is start by plotting the points that I know. So I'm going to move the screen down just a little bit. And there are some points that I have. Remember that I have the point x equals 0, y equals 1, and that is the absolute max. Then I have the point f of 1 is 0, and because it's an even function, I have f of negative 1 is 0. Then I have f of 2 is negative 1, and consequently f of negative 2 is negative 1. And so from this point, all I need to do is find out what is happening between 1 and 1, between 1 and 2, between 0 and 1, between 1 and 2, and 1 and 3, between 0 and 1, 1 and 2, and 2 and 3, those three intervals, and then reflect those over the y-axis, and I'll be done. So I'm going to go back up to look at the table for just a second. And you recall my notation between 0 and 1, I said that the function is positive and it is decreasing and it is concave up. And there is a horizontal tangent at x equals 1, y equals 0. So I make that that curve segment there that is decreasing, concave up, and comes in for a smooth landing for a horizontal tangent at x equals 1 and y equals 0. Then from x equals 1 to 2, I'm leaving that horizontal tangent, so I need to be starting off on a horizontal tangent, and the function is negative, it is decreasing, and it is concave down. And so you can see that I have a horizontal tangent at 1. After that point, the function is negative, it's decreasing, and it's concave down. Now from 2 to 3, the function stays negative, but it's going to be increasing and concave up. And concave down. So I draw something like that, and recall that at 2, negative 1, I have in green right above the graph that I should have a sharp turn or a vertical tangent, which I do. Now I don't know where f of 3 is, so I just leave it, but I do know that it's negative. And then I'm going to reflect this over the y-axis, and I've used all the information. I should go back and double check, but that I'm going to run out of time on this video. You should go back and double check that everything that we identified from the table and from our analysis shows up in the graph, and so it has all the characteristics we want.